Alrighty, for 2.4, we're going to be looking at a mixture of variables where we're going to have quantitative and categorical variables mixed together. More specifically, we're going to be looking at box plots. Box plots are a way to summarize a five-number summary. We're also within those box plots going to look to see whether any data values happen to be outliers. And what we're going to start with is what's known as these two little formulas here. And the purpose of these are they just call it a rule of thumb, a set of calculations that you can do to create what are called either cutoffs or fences. And if any data value is beyond those cutoffs, then it would be considered an outlier. So let's go ahead and get started. First of all, we're going to have those two little formulas. And when we do the first cutoff, it's going to be to see if there's any values that are less than that cutoff. And I went ahead and did sort of like a little diagram that, this is the little formula, the little calculation we're going to do. And if there are any data values that are beyond, I'm just going to extend it even more. Right. It's going to be sort of like just this invisible line. Anything that's to the left of that value wise would be considered an outlier. And we usually use these two little dots to signify uh, outliers. But then we've also got possibility that there could be some data values that are greater than this cutoff, which is taking the first one was taking the first quartile and subtracting 1.5 times your IQR. And then to check for uppers, you take the third quartile and you add 1.5 times your IQR. And I'll show you down below when we do our first example, like what's the 1.5? Where does that come into play? And it has to do with a matter of distance. But if there's anything beyond that cutoff, then that would be considered an upper outlier, just something that's unusually large or much different than the rest of the data values. One thing you'll for sure need is for the IQR, that is the interquartile range, which takes your third quartile minus your first quartile. So it's not the range, like it's the max minus the min, it's a range within inside the data. For your five-number summary, again, that's got the minimum, the max, it's got your median, which is your 50-50 split, but then it's got your first and third quartiles, which are splitting it into um, four quarters, so like 25%, 75th percentile. But this is the box plot. Yeah, down at the bottom of the page, we got a box plot, which is a really, really nice way to be able to see sort of a quick summary of your data values. Again, right now, just quantitative information. And some of the main superstars in this are, well, I'm going to start with the box itself. If you put a little line down here pointing at that thicker, bold line, that's the median. Which again, remember that what the median does is it splits the data 50-50. So here, I'll try to shade it. Like this right here would be, 50% of your data. And then on the other side would be the other 50% of your data. And then the rest of the box, that line that you see there, again, it would correspond to some number, you know, some sort of value. That would be your first quartile, which is taking your your lower 50% and cutting it into 25% and 25%. And then right here, you've got your third quartile. Now, that's your 75th percentile. And I'm going to shade it real quick. This box itself is 25% and 25%. Again, the reason why one 25% might be larger than another 25%. Again, you don't have to put these in your notes, but this would be 25% here, and this would be 25% of your data on the other side. Again, there may be just a slightly different range of values, within each of these 25%. But right now, the main thing is the diagram is that you've got your median, your Q1, your Q3. And then right here, This could be thought of as like a data value. I just put a dot there. Like somebody had a value of 0 or whatever they were measuring, and then right here that would be the smallest value, so the minimum. Now, if you get over here and you start thinking, well, then probably right there would be the maximum. But no, anytime you see something like this, that's like this little oval or this little open circle, that would be an upper outlier. Like most of the values were between like 0 and 40. But then for some reason, there was this other unusual, I don't know what I just did there. Somehow I just got rid of my whole screen. Ah, there it is, coming back. There it is. Um, Yeah, that right there is some value that seems unusually distant from the rest of the. Oh, I do want to keep that. Um, than the rest of all the other numbers in the set. And so, anytime you do have an upper outlier, we do have to consider those. Those are part of the data. And so now this would all of a sudden become the max value, right? 52 or whatever it is. And so, if you're looking, well, what about this little dot that was hanging out here? That would not be an outlier. It would be here. I'm just gonna do a little arrow to it. Just do this. This would be a large data value, but not an outlier. Now you won't see them, so I'm kind of hesitant to do it. But whenever I talk about there being a like a cutoff for what should be counted as an outlier, maybe I'll go ahead and do it here. The IQR, the interquartile range is this. It's the distance from your first quartile to your third quartile. And what the cutoff is doing is saying if there's anything that is that distance and another half, it should be considered an outlier. So here, let me try to see if I can do this. So let's say right here, this is your where your third quartile is, and I'm going to take that distance and I'm going to go off here, do like one of those, and then I'm going to do a half of this, like another little half. And so that would be what the rule of thumb is saying is that if you have anything that is more than 1.5 times your IQR beyond the rest of the data, then it should be considered an outlier. And that's this guy's like, wait, why are you on the other side of that dashed line? That's that it's being, it's just unusually large. And you don't have to keep that little red stuff in here. I just did it for like the sake of visualness, and I'll maybe do it again on the next, the actual example we do. But that's your 5 number summary. We either use like these little circles or maybe like a little star, or sometimes I've seen like boxes get used to represent outliers. So let's actually go ahead and use this within an example. This is the 50 states for the United States and their populations. Certainly, yeah, some states have larger populations than some other states. But what's happening on here is you can see, there's a minimum, there's a state that has the maximum, like the largest population versus like the smallest population. But what we're going to do with this example is see if any of these smaller states or any of these really large states over here are so unusual, are unusually small or unusually large that they should be deemed outliers. Now, what's going to get us set off are these two. What's going to get us in motion is taking Q1 and Q3. We're just going to go right here, and this is known as the IQR method, where you take your Q3 minus your Q1, and you just subtract them, which would be a 6.7 minus a 1.7. And whatever you get from that is the IQR, the interquartile range. And that's going to give us a 5. Now, I like to put that in parentheses. The main reason why is because it's going to get plugged in twice as we're checking for the two types of, lower outliers, upper outliers. Now, when you're doing your homework, I don't need you to start off with this little formula, but when you're doing the lower outliers, Like this is what you use. And maybe what I do if you're working through the lecture handout is just kind of cut this in half because we're going to also check for lowers and we're also going to check for upper outliers at the same time for this example. And so you get your Q1, which again, Q1 is the 1.7 minus 1.5 times the IQR. Now that's something that you would just want to put into a calculator, and it's going to give you your lower cutoff. And anything's below than that lower cutoff, then it should be counted as being an outlier. But notice that when you put this in your calculator, you get this. And this, again, it's like a surprise. You don't know what you're going to get until you get it. We got this negative 5.8. And this would be checking to see if any of these smaller states over here were lower outliers. But in terms of like a cutoff, here would be negative 5.8. And as we can see, there's nothing that's lower than that, which means each of these smaller states in this little corner are not outliers. So they're states with small populations, but not unusually small that they should be, called outliers. And this is what you would want to do in your homework. You would want to show how you got your cutoff, and then you would want to state your conclusion. In this case, there are no lower outliers. But that one uses Q1, the first quartile. For checking uppers, it uses the third quartile, which is going to be the 6.7. You would take your 6.7 plus 1.5 times 5. You see what you get. Again, just put that in your calculator, and I want you to go ahead and do this one, maybe even pause the video and then check once you get your cutoff. If there's anything bigger than that cutoff, then that state would be considered a state that has an unusually large population as compared to the rest of the other 50 states. All right. Now you should have gotten 14.2. And now I'm going to take that 14.2, and here's these big states. And right about here would be 14.2. That's your cutoff. And anything bigger than that is a state with an unusually large population. So you would have 1, 2, 3, 4, and I'm going to assume those are probably like California, New York, Texas, the other I'm not Florida maybe. So you got these four different states, and so and usually what it'll tell you on like the homework or the quiz or test is like to identify them, and there just by circling them, that's our four outliers, and then you'd want to state your conclusion. There are four upper outliers. But the big main thing is when you're doing your homework, make sure that you show me. For a lot of the homework, it's really not necessary to show me work if it's small, like just numerator denominator calculation or like a plus minus kind of thing. But for this one, yes, definitely need to see that you carried out the IQR method and showed your cutoffs, and then state your conclusions. Either there are or there are not outliers, and if there are, which ones. All right. Now, with each set of quantitative information, we can build a graph of a box plot. Now, when you do this, it's going to end up being, a box with, some whiskers on it. But let's start with the box. That's going to be these. It's going to be the Q1, the median, and the Q3. And your median is the one that's going to be the center vertical bar. So 4.2, let's start there. Median is 4 here. And I got us kind of started here with a little already a rectangle with some dashed lines. That'd be kind of where 4.2 is. And then you're going to do the rest of the box, the Q1 and the Q3, which is the 1.7 and the 6.7. So let's try those. 1.7 and 6.7. Maybe this is a good spot for 1.7. And then here would be 6. It's maybe about 6.7. All right, and then we'll go ahead and close off the box. And then now we start working on the whiskers. Now I always do the whiskers, the little lines come up to the side whenever there's no outliers first. So remember, none of these were outliers. So it should just be a straight line that goes from the box over to 0.51, the minimum. Where again, wherever you think 0.51 is, I mean, I'm just gonna go with maybe here. Yeah, that be touching the state that had the smallest population. And then we go to the other side. Now, this is the one we had some outliers. So here's what's really important is that let's say you had outliers over here, which I just did those really quick. Your bar should not go and touch those. It should stop wherever you've got a state that was not an outlier. So in this case, the 12.712 should be where your whisker stops. And then you'd have the 17, the 19, the 22, and the 35, 36, right? 30, 36-ish. So let's do this. 12.7. But again, if this is 10, 11, 12, again, it doesn't have to be perfect. Just kind of doing a rough sketch here. A little bit after 12, right? Again, I did my best, my best there. Um, and then you'd have your outliers. So one of them was 17. Here, we'll go back up there real quick. You got your 17.3, your 19. Let's do those 17 and 19, 17-ish, 19-ish. And then you can see the other ones at 22, and then 35.8, which is, just right about there. And that would be the box plot that corresponds to this set of population sizes for the United States. So all 50 states are in this graph. We can see four of them for sure. The other 46 are within the box and within that those whiskers. All right, and we'll do another one of these in just a moment to kind of get hopefully get the routine, settled. And that's really is like the big main gist of this 2.4 is like the box plots. There's a few that we'll go ahead and do just to really set this foundation down. Is that whenever you see a box plot and if it asks like are there any outliers and you see stuff like this, either little circles or asterisks or little boxes, you'll say yeah, yes, there's some outliers. And you could do the same, just like we saw with like skewed left, skewed right, symmetrical bell shape. I mean, you can pause the video real quick, and all I want you to do is, kind of vote for whether this is skewed left, skewed right, symmetrical bell shaped. And if it weren't for these, you'd probably be saying symmetrical bell shape. But because there are those two outliers, we would say, well, it's got the one hump, it's got the tail over there, and then it's got this longer tail over here that would make it what makes most sense is that it's skewed to the right. It's got some extra stuff to the right that doesn't really balance off well with the other left side. Then the only other thing to do with this is it's asking us to do an estimate of the 5 number summary. And again, if anything, this is just to kind of recap what we talked about a moment ago. Is that this right here? These three are your Q1, median, and your Q3. Again, just estimate those, 37,000, 39,000, and maybe 44,000. And the context of this is about the gross. It's the gross state product for all of the 50 United States. And then when you're doing your 5 number summary, we've also got our min and our max on the outside. And I know why I picked this example. If this is the min right there, maybe like 27,000, 28,000, you got to be more careful in these situations where this is not the max. right? So I'm going to leave that off. That is a data value that was large, but not an outlier. So we've got one here and we've got one there. It's this one though. That's the max. Yeah. So whenever you have outliers, they are part of the data. You must use them. Don't ignore them. So our max would be something like 67, 68,000. Now we'll do one in a moment, and on this one, I think there's probably a bigger chance where you and I, if we were doing these estimates, might not, get exactly the same numbers estimate. And again, like I've said on some of the other for the other homeworks, is that as long as your estimates are pretty close to like the answer key, don't count them as being wrong. Just know with estimate stuff, we're going to be maybe be just a little bit off, and as long as we're just a little bit off, that's okay. All right. This one's just a quick self quiz. So go ahead and pause the video, try it for yourself. It's just doing what's the five number summary, the min, the Q1, the median, Q3, and the max. And then the other thing for part B is where is the 50% interval in between. And that I mentioned on the very first page, but it's going to go from here to there. That's your middle 50%. And then once you have your five number summary, you'll be able to answer B. And you'll also be able to do the range, which is your max minus min, your min, and your IQR, which is your Q3 minus Q1. So again, go ahead and pause the video, try these for yourself, and then watch the next part. Okay, so for this, it should have been 78, maybe like 83, 87, 89, no decimals needed, and 92. So 78 for the min, 83 for the Q1, 87 for the median, 89, and 92. And so with those, that should match with our answer for part B. 83 and 89 would be where the middle 50% like starts and stops. And then now just using our max and our min, we get a range of 14. And using our 89 and our 83, we get a IQR of 6. All right, cool. All right, let's try something else. And now these, I really, really like these. This is a side by side box plot. And the reason why I like these, it's like this could have been four different box plots that they graph separately, but having them side by side is really nice because now you can do comparisons between groups. And this study was about smoking, and you can look at, let's just for example, let's say we looked at just the bottom. That's the western region of the United States, and that's got a certain number of the 50 states. And one of the states right there that I just put a little hash mark on was a state that the percentage of people that smoke in that state is like maybe like 12%. But then one of their states, right about there, whatever state that is, about 25% of them smoke. And that's just for the western region. You can see the other, this is Midwest, this is Northeast, these are the southern states, and then these are the western states. So all 50 states are now broken into four different regions. And again, this is meant to compare like which region has people who are smoking more often. And then what A is going to do, got to be careful here. The way that it's asking, saying like in general, which region tends to have more people who are smoking. Now, the way to do this, the best thing to do is like, well, since some of these are like more spread out than others, the best thing is just to compare one number for each. And that's going to be this, the median. Again, the median is like the mean. It's trying to give us sort of like a in between or like a middle number, right? And so that Midwest region, if you look straight down, generally it would have for its central tendency about 21% of the of people in that region are smoking. And if you do the Northeast, just look straight down, they're like 19, almost 20. Then if you look at the South, kind of centrally for them would be about 23. And then for the Western, like 18 or 19. And so just use the medians to do in general, like which is more to the right. Well, that's going to be the South. They've got about, in general, about 23 percent of people in that region who are smoking. So the Southern would be the winner for part A, which is, you know, not something that you want to be winning, right? And then for B, that's now where it switches. And now it says which region contains the state, where if you look just at the state, they have the highest percentage of people who are smoking. And again, remember, sometimes we can't see specifically like a state that's like floating out by itself unless it's an outlier. And that's going to be this one right here. And if you look straight down, whatever state that is, I don't know what it is, you can Google it. It's got like almost 28, 29% of people there, almost like a third of people in that state are smoking, which that belongs to the Midwest. And then which one had the greatest variability, most spread out? It's got the Western has some states that are like in the teens. It's got some states that are in the 20s. So it's got more variety. So yeah, I really like the side by side box plots because of the ability to be able to compare whenever you got two, three, four groups. All right, as I mentioned, I wanted to do at least maybe one more um, of these kind of walk through the IQR method just to get it really like hopefully as nailed down as we can before we end this lecture. And then I want to do one small like stack key thing before we go. Okay, so when you get to the homework, there's going to be one where they give you the Q1 and the Q3. And then, of course, yeah, we got the median, the min, and the max. But right now, I'm focusing just on the Q1, Q3, because they want us to check if any of these 120 numbers is either a lower outlier or an upper outlier. And you're like, wait, where's the 120 numbers? They're only giving us just the tail ends, like the minimum and some of the numbers close to it, the maximum and some of the numbers close to it. And so let's go, let's do this. Again, what I would do if you're working off the lecture handout is just split this, and we're going to start with the first just with the IQR. Okay, remember that's the Q3 minus Q1. Yeah, I'm going to go ahead and do it. Right, I'm just going to do Q3 minus Q1, which would be we got the 56 minus the 42, which gives us 14. And now you're going to do checking for lowers. We're going to see if any of these happen to be lower outliers. And for that, you'll do the Q1 minus 1.5 times the IQR. And so let's go to put those numbers in. It's the 42 minus the 1.5 times 14. You're going to crunch that into your calculator. And then whatever number you get, it's like a surprise. You're going to get a number. It's not a data value. It's to see if there's any of these numbers happen to be lower than that, then they'd be a lower outlier. And when you do this, you should get 21, which is your cutoff. Now let's go there. Here would be 21. and anything below that is a lower outlier. So we can just go to put circles around them. 15 and 20. So we got two lower outliers, 15 and 20. And we'll use those in a moment whenever we draw the box plot for this. And go ahead and do the upper outliers. I mean, I'm going to give you a quick little recall. It's taking the Q3 plus 1.5 times your IQR. So go ahead and do that. Do that in the little calculation in your calculator. You're going to get your cutoff and you're going to see if anything is an upper outlier, like if any of these are unusually too big. And then once you do this, whether you find outliers or not, you want to go ahead and put your conclusion like, yes, I found some outliers, this number and this number. Or if you don't find any, then go to put that as your conclusion. Like, report to me what you discovered. All right, here it comes. It's gonna be 56, which is our Q3 plus 1.5 times our IQR, which gives us 77. And as you look over here, there's nothing bigger than 77. So these are all safe. They are not, they're large values, but they're not upper outliers. No upper outliers. And let's go to draw a box plot. Now, when you do this, you just want to keep in mind how wide you need. You need something that goes all the way from 15 to 77 to 71. And so what we can do is just, since there's no starting box here, we'll just go from 10, 20, 30, 40, 50, 60, 70, and we'll go 80. That should be plenty to fit all of our our box and our whiskers. Let's start with the box, which is going to be all right, the 42, 52, and 56. Q1 median and Q3. 42, 52, and 56. I'm going to start with the 52. And again, when you do the homework, I mean, you don't have to, worry too much about being super, 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 super accurate. It's just a rough little sketch. There's about where 52 is. Then we'll do the 42 and the 56. And that's good enough. 42 to 56 with the 52. Again, it could be a little bit more accurate, but this will work. And then I want to do the whisker that comes out to the side here because it didn't have any outliers. So those are usually a bit more straightforward. It's going to go from, it's going to stop at 71. Boom. And you don't have to put a little dot at the very end. That would signify that there is a data value that went up to that point, but it's just that's the end of the road there. And then now, again, we had two outliers over here, and we just want to make sure that whisker doesn't run into there. Right? The dots are supposed to be floating out in space that are the outliers. So remember, there is a value that was just before the ones that were called the outliers, which would be the 28. That's where you would stop your whisker, and then 15 and 20 would be floating out in space by themselves. And that would be your box plot that matches this set of data. All right, last thing. All right, we're going to do a stat key example here. And again, for all your stat key, these are the ones that you want to make sure that to receive credit for your homework that you're actually um, making sure that you attach these as evidence of, hey, I went to Stacky, I made the graph. What we're going to do on this one is there's a study about nutrition, specifically about calories based on sex. And so we're going to make a side by side box plot. We're going to go here, one quantitative, one categorical. And whenever you get there, you should see in the drop down something about nutrition study, calories by sex. And you can actually start going there for yourself and starting to find it. Yeah, it's there. Nutrition study, calories by sex. And I've actually on my laptop already pulled it up, but let me go to do it here. And while you're doing that, let me also just what's the purpose of this? This is, does there appear to be an association between calories consumed and sex? If so, describe the association. So, in other words, if you're male versus female, does one of the groups tend to eat, maybe, consume more calories than the other group? Right. And you might already have a hunch like, yeah, usually if you're male, you're going to do more or less calories than as opposed to the females. And I'm already looking at it in my laptop here, but let's do it. Right, all I was trying to do there is just stall. And let me go ahead and close this. Let me go over to, I want to go to stat key. Oh, actually, I got it right here. So here's where you should be, right there in the middle, one quantitative, one categorical. And again, a lot of these first stat key exercises that we're doing are meant to be sort of just click here, click there, boom, you're done. Just to kind of get us the initial like feel for stat key and to see how easy or just straightforward they're supposed to be. You can see it right there, the nutrition study, calories by sex. Let's click on it. Now, this is the side by side dot plot. Let's click on where it says box plot. Now you can see for the men versus the female who tends to eat more calories, and they're not the same. Yeah, you can even just looking here, you can see that the 50% of the blue box is more to the right, kind of like straight below for the median. You can see like 2000, and then for the female, this brownish box is kind of like 1500. But you don't have to base it off just looking at those. They actually have the numbers over here. You've got the mean for males is like 2100, females is about 1700 calories. The medians, likewise, male is about over 2000, females is about 1600. And so this is an example. What we mean by there is an association, is that if you are male, males tend to consume more calories on a daily basis than females do. Right. And maybe we're not totally surprised by that. But this is, if this was your homework example, you would go and take like a little screenshot of it, you would attach it with your homework, and then back on the actual like homework, you would make your conclusions like, does there appear to be an association? So you don't just answer the question, you answer the question and you also attach your stat key with it. So you would say, does there appear to be an association between calories consumed and sex? Yes. And then you would say, describe it. You'd say males tend to consume more calories. And that's it. Just something short, sweet, and simple. But that is it. That is our 2.4. That is also the conclusion of the sections for Unit 1, which means we should now start thinking about making sure that we've got a nice reference sheet put together. Again, remember, you can use a reference sheet during test 1 to help you out. And no other notes, no other resources, just you, your calculator, and your reference sheet. That's going to be a one-sided reference sheet. And you're able to use those during the test. But let me go ahead and end this recording. And again, reach out to me if questions come up.